Engine block. The engine block is like the foundation of a house, holding all the vital components together. It's typically made of strong, durable metal and houses the cylinders, pistons, and crankshaft. Within the engine block, you'll find cylinders, which are cylindrical chambers where pistons move up and down. These pistons are connected to the crankshaft via connecting rods. The crankshaft, a long metal shaft, converts the up and down motion of the pistons into rotational motion. This rotation powers your car's wheels, propelling you forward. To control the opening and closing of valves, there's the camshaft. It ensures the precise timing of air and fuel intake and exhaust expulsion, crucial for engine performance. The valves, located in the engine head, regulate the flow of air, fuel, and exhaust gases in and out of the cylinders, synchronizing with the movement of the pistons. So, think of the engine block as the core structure of your car's engine, housing and connecting all the essential parts needed for combustion and propulsion. Cylinders. Cylinders are the powerhouses of your car's engine. These cylindrical chambers are where the real action happens. Inside each cylinder, you'll find a piston that moves up and down. As the pistons move, they create the energy needed to propel your car forward. The number of cylinders in an engine can vary, with common configurations being 4, 6, or 8. More cylinders often mean more power. Each cylinder works in sync with the others, firing in the correct sequence to keep your engine running smoothly. So, the next time you hear about cylinders, remember, they're the driving force behind your car's performance. Pistons. Pistons play a vital role in the combustion process. As they move downward, they draw in a mixture of air and fuel into the cylinder. Then, as they move upward, they compress this mixture, preparing it for ignition by the spark plug. When the spark plug ignites the compressed mixture, it creates a powerful force that drives the piston back down. This downward force is what ultimately turns the crankshaft, converting the linear motion of the pistons into rotational energy. Pistons must maintain a tight seal within the cylinder to ensure maximum efficiency and prevent loss of power. Additionally, they need to withstand high temperatures and pressures generated during combustion. Proper maintenance and care of pistons are essential for the longevity and performance of your engine. Crankshafts. Crankshafts are the backbone of your car's engine. These long metal shafts are responsible for converting the up and down motion of the pistons into rotational energy, which ultimately drives your car's wheels. Connected to the pistons via connecting rods, the crankshaft rotates as the pistons move up and down inside the cylinders. This rotational motion is transferred to the transmission, which then drives the wheels. Crankshafts are carefully engineered to withstand immense forces and high speeds, ensuring smooth and efficient operation of the engine. They must also maintain precise balance to minimize vibrations and maximize performance. Without a properly functioning crankshaft, your engine simply wouldn't run. So next time you're on the road, remember, it's the crankshaft that's keeping you moving forward. Camshafts. Camshafts are responsible for controlling the opening and closing of the intake and exhaust valves. The camshaft is synchronized with the rotation of the crankshaft and is typically driven by a timing belt or chain. As the camshaft rotates, it pushes against the valve lifters, causing the valves to open and close at the precise times required for optimal engine performance. Camshafts come in various configurations, including overhead camshaft, OHC, and overhead valve, OHV, each with its own advantages. Whether it's ensuring efficient fuel intake or effective exhaust expulsion, the camshaft plays a crucial role in determining your engine's power and efficiency. Valves. Valves regulate the flow of air, fuel, and exhaust gases in and out of the cylinders. There are two types, intake valves and exhaust valves. Intake valves allow air and fuel to enter the cylinders during the intake stroke, while exhaust valves allow exhaust gases to exit during the exhaust stroke. They open and close in precise coordination with the movement of the pistons, ensuring optimal engine performance. Valves are controlled by the camshaft, which determines their timing and duration. Proper valve operation is essential for maintaining engine efficiency, power, and emissions. Timing belts. Timing belts synchronize the rotation of the crankshaft and camshafts, ensuring valves open and close at the correct times. They're crucial for the engine's four-stroke cycle: intake, compression, combustion, and exhaust. If the timing belt chain fails, engine timing can be thrown off, leading to serious damage. Belts are made of rubber with reinforced fibers, while chains are metal and typically more durable. Regular inspection and replacement per manufacturer recommendations are essential for engine health. Engine head. Engine head sits atop the engine block, sealing the cylinders and forming the combustion chambers. The engine head contains the intake and exhaust ports, as well as the valves and spark plugs. It plays a crucial role in the combustion process, ensuring proper airflow and sealing the combustion chamber for optimal performance. Engine heads are typically made of aluminum or cast iron for strength and heat resistance. They must maintain a tight seal to prevent compression loss and ensure efficient engine operation. Intake manifold. Intake manifold is responsible for distributing air, and sometimes fuel, from the throttle body to the individual cylinders. The intake manifold ensures an even distribution of air-fuel mixture, optimizing engine performance. It's typically made of metal or plastic and consists of passages or runners that direct airflow to each cylinder. Some intake manifolds also feature a plenum chamber, which helps equalize airflow. The design of the intake manifold can impact engine performance, with factors like runner length and diameter affecting airflow dynamics. Exhaust manifold. Exhaust manifold collects exhaust gases from the cylinders and channels them into the exhaust system. Typically made of cast iron or stainless steel, the exhaust manifold withstands high temperatures and pressure. Its design plays a crucial role in exhaust flow efficiency, with equal-length runners optimizing performance. Some exhaust manifolds feature integrated catalytic converters to reduce emissions. Proper maintenance is essential to prevent leaks and ensure optimal engine performance. Without a functioning exhaust manifold, your engine's efficiency and emissions control would be compromised. Fuel injectors. Fuel injectors are responsible for precisely spraying fuel into the combustion chamber or intake manifold. They are controlled by the engine's electronic control unit, ECU, which adjusts fuel delivery based on various factors like engine speed and load. This precise fuel delivery ensures efficient combustion, maximizing engine performance and fuel efficiency. Modern fuel injectors use advanced technology like solenoids or piezoelectric actuators for precise control. Regular maintenance, including cleaning and inspection, is crucial to ensure optimal injector performance. Without properly functioning fuel injectors, your engine's performance and fuel economy would suffer. Spark plugs. Spark plugs ignite the air-fuel mixture in the combustion chamber by generating a spark. This ignition process is timed precisely to ensure efficient combustion. Spark plugs come in various types, including copper, platinum, and iridium, each offering different performance characteristics and longevity. They must withstand extreme temperatures and pressures generated during combustion. Proper maintenance, including regular inspection and replacement as needed, is crucial for optimal engine performance. Without functioning spark plugs, your engine wouldn't be able to ignite the air-fuel mixture, leading to poor performance and potentially damaging effects. Oil pan. The oil pan is a reservoir located at the bottom of the engine that holds the engine oil. It's typically made of steel or aluminum and is sealed with a gasket to prevent oil leaks. The oil pan also contains an oil pickup tube, which draws oil from the pan and delivers it to the engine's moving parts for lubrication. Proper maintenance of the oil pan, including regular inspection for leaks and damage, is essential for engine health. Without a properly functioning oil pan, your engine wouldn't receive the lubrication it needs, leading to increased friction, wear, and potential damage. Oil pump. The oil pump pressurizes engine oil and circulates it through the engine to lubricate moving parts such as the pistons, crankshaft, and camshaft. It ensures proper lubrication, reducing friction and heat, and prolonging engine life. The oil pump is typically driven by the crankshaft via a gear or chain. Regular maintenance, including oil changes and filter replacements, is crucial to keep the oil pump and engine running smoothly. Without a properly functioning oil pump, your engine's moving parts would suffer from inadequate lubrication, leading to increased wear and potential damage. Cooling system. The cooling system regulates the temperature of the engine by dissipating excess heat generated during combustion. It consists of several components, including a radiator, coolant hoses, thermostat, water pump, and coolant. The radiator, typically located at the front of the vehicle, removes heat from the coolant as air passes through its fins. Coolant hoses circulate coolant between the engine and radiator, while the water pump ensures proper coolant flow. The thermostat regulates coolant flow by opening and closing based on engine temperature. Coolant, a mixture of water and antifreeze, absorbs heat from the engine and transfers it to the radiator. Proper maintenance of the cooling system, including regular coolant flushes and inspections, is essential to prevent overheating and engine damage. ECU. The ECU, Engine Control Unit, is the brain of the engine management system, responsible for monitoring various sensors and controlling engine functions. It receives input from sensors such as the oxygen sensor, throttle position sensor, and mass airflow sensor, then uses this data to adjust fuel injection timing, ignition timing, and other parameters. The ECU ensures optimal engine performance, fuel efficiency, and emissions control by continuously adjusting these parameters based on driving conditions. Modern ECUs are programmable, allowing for custom tuning to optimize performance for specific applications. Proper maintenance of the ECU, including software updates and diagnostics, is essential for optimal engine operation. Wasn't that fascinating? Join me in next video as we dive into even more captivating topics. If you enjoyed this exploration, don't forget to spread the word. Like, share, comment, and most importantly, subscribe to my channel. See you then.